Hello and welcome. My name is Brian Kirk, and I am a PhD student at New Mexico Tech working within the Cosmic AI Institute. Today, I want to talk to you about how we are using reinforcement learning in radio astronomy. Radio waves let us observe hidden physical phenomena that regular telescopes cannot see, as seen here in the image of our Milky Way galaxy. The top half reveals what we observe at radio wavelengths, while the bottom half shows what we see in the visible wavelengths. And to get the best view with extreme resolution, we use a technique called interferometry, which combines many smaller dishes to act together as one giant telescope. However, this comes at a steep cost. It makes the resulting data incredibly complex to process before we can extract the science. And this complexity brings us to our biggest challenge, which is the data deluge. Historically, the heavy burden of processing this data fell on the astronomers themselves, which presented an enormous learning curve and a barrier to entry for those who might have been interested in using the data. However, our modern telescopes are capturing data faster than we can train humans to process it. And to cope with this data deluge, domain experts create generic processing templates. But it is a one-size-fits-all approach. And to do great science, users still have to spend countless hours manually fine-tuning these templates to fit their specific data best. So, how do we remove the human bottleneck? You might recognize this famous artificial intelligence milestone when DeepMind's AlphaGo defeated Lee Sedol in the game of Go, or when DeepMind's AlphaStar learned how to play complex video games at a superhuman level. Both of these systems used reinforcement learning as their engine to solve complex strategy. My research utilizes the same machine learning approach, reinforcement learning, to tackle a completely different challenge. So just as those systems learned optimal strategies to win matches, our AI agent learned how to act as a virtual domain expert. So instead of relying on generic templates, this data-driven agent looks at the specific characteristics of the dataset and tailors the processing perfectly to it, giving each dataset individualized treatment. And building an agent like this, however, is no small feat and requires thoughtful design. And in our research, we use a vast distributed network of computing resources from the Open Science Grid to run our training, which taps into 86 different sites across 54 institutions. The payoff for achieving a working agent is massive. Because an AI agent can be instantly duplicated, it entirely removes the bottleneck of a limited number of human experts. So in summary, generic processing templates currently require too much manual fine-tuning. We use reinforcement learning to train an AI domain expert that customizes processing for each dataset. And because this AI agent can be easily replicated, it removes the human bottleneck from data processing. This approach allows researchers to focus purely on cosmic discovery without needing any specialized data processing skills. And if you want to stay up to date with AI and astronomy, check out cosmicai.org.